Welcome, everyone. Today, we have a conversation with Thomas Dinsmore, a renowned expert in machine learning and machine learning tools. Thomas has held various positions at leading data science companies, focusing on competitor intelligence and product marketing. Given his experience, I'm sure that we are up for a very interesting conversation about the value of machine learning, AutoML, and generative AI. So welcome, Thomas. Let's get started. So you have spent several years in competitor intelligence. Could you comment on the content of such a role? How do you gather information and how do you actually validate it?
Okay. Great. Thank you. And thank you for having me on this. First of all, I've worked with machine learning and data for 40 years. I've worked full time in competitor intelligence for 6 years for two companies, Data Robot and Domino Data Labs. Prior to that, I was with Cloudera and some other companies where I was doing competitor intelligence as part of a product development role. You mentioned product marketing. One of the things I've observed is that competitor intelligence sometimes resides within marketing, sometimes it resides within product, sometimes it resides elsewhere. When I was with Data Robot, I was always the head of competitor intelligence, but I actually worked, at one point I worked in the executive team, another point I worked on the marketing team, another on the sales enablement team. So the role tends to float. There are typically three different types of clients for competitor intelligence, and the role that you play depends on your clients. So the clients can be the executive team. In other words, the CEO or other members of the C team want to know about competitors, and their questions tend to be timely and topical. In other words, they learn that, let's say, Microsoft is acquiring a company. What are the implications for the competitive landscape, right? Um, the product team tends to have a very different set of questions because the product team is looking to develop long range plans. They're planning to make investments in the product. So they want to know, they need a kind of a far reaching understanding of competing products. They need more of a teardown. They need to understand not just what a competitor's product is today, but what is the likely direction of development, because the product team actually has to aim for what the competitive landscape will be like in a year, 2 years, 3 years. The third group of clients, and the most frequent group of clients that I found working in Compintel, is the sales team. And the sales team is primarily interested in FUD. They want to plant fear, uncertainty, and doubt about competitors' products. So they are looking for messaging and tactics that they can use to remove a competitor from contention in a competitive situation. Marketing, I find, seems to be less interested in competitive intel, although arguably they ought to be more interested. But to the extent marketing is interested, they're interested in things like what are competitors saying in the marketplace? What is their messaging? What is their top line positioning? So the bottom line is, if you're in the competitive intelligence role, you adapt your techniques and your methods based on which of those key roles. In other words, are you supporting sales, marketing, product, or the executive team, or all of those? Um, when you're when you're focused on the sales team and providing FUD, your sources of information are typically going to be very simple. You read the documentation, read the competitors' documentation. Most products nowadays they publish their documentation. And if they don't publish their documentation, you use that as FUD. Hey, that company is so embarrassed by their product, they're not willing to share their documentation. And that actually works. But it's remarkable what you can learn just from reading the documentation. Because, and why does that matter? It's because companies typically warrant their software products based on what it says in the documentation. So a licensing agreement will say, we warrant this product performs according to our documentation, which means if it's not in the documentation, they don't warrant that. Right. And
Mhm.
so when you're doing comp and tell and looking at the documentation, you're looking for gaps between their messaging and what they actually say they have in the product, right? And that's something you can exploit. You feed that to the sellers. Um, for product, the if you're supporting the product team, you're going to be more focused on hands-on actual trial or benchmarking of the product. What people in R&D and product would call tear downs, right?
Mhm.
And for the executive team, it's whatever based on the product. Um, yeah, so that's how you gather information. How do you validate it? Well, when you're feeding information, competitive intelligence to the sales team, you validate it based on whether it works, right? In
Mhm.
other words, and how does that work? Well, I would typically give the sellers a list of here's the top 10 talking points against this product.
Mhm.
And if a seller gets back to me and says, I tried that and the customer says they couldn't care less, right? Then I would drop that and plug in something else. So ultimately, the validation is, do the sellers appreciate it and like it and say it's helpful, number one, and number two, do they win with it, right?
Mhm.
That's ultimately the validation. With product, it's a little bit different. You don't There's no really way to validate it. If you're doing a benchmark, you just do the most accurate work you can. Does that answer your question?
It definitely does. I'm quite interested as well in, say, timely and topical aspects. Like as you mentioned, C-level is mostly interested in competitive intelligence at a given point in time. And I would imagine that generally speaking, documentation and also beta versions of software, the tools that you use for supporting sales and product teams, that they might always lag a bit behind. So I was curious to understand how you try to get as recent as possible information from competitors to address questions from C-level.
Well, the questions from the C level tend to be quite different than the questions you get from sellers. So,
Exactly.
an example is when I was at Data Robot, there was a lot of interest in the IPO of C3.ai and the
Mm-hmm.
IPO of Palantir. That was back in 2020,
Mm-hmm.
2021. I can't recall the exact year. And so for those two, I was spending time reading the S1 registrations, the financial statements, and kind of ripping into the financials because that's what the
Yes.
management team was interested in. As I say, the executive questions are ad hoc, right?
Mm-hmm.
And so you have to just sort of rely on your source. I have a network of people, within a company, for example, if you're responsible for competitive intelligence, you identify certain people within your company who have some expertise in certain competitors. Maybe they work there, right? Maybe they were a customer of that company. So you kind of develop these sources, but there's no magic to it. I can't boil it down to a silver bullet. It's something you
Of
develop
course.
over time. The reason I got selected into the comp intel role at Data Robo was just that I'd been working with this stuff for a long time.
Mm-hmm.
It's not like you go to you go to Coursera and take a course in comp intel. No, you get into this because you develop a reputation for just being
Mm-hmm.
familiar with these products and being able to make an educated guess.
Yeah, exactly. Okay, well, you mentioned a few times data robots already. Data robot is a great example of software that helps with so-called AutoML futures, machine learning models and use cases that are built almost automatically. As you worked for such a long time with these type of companies, could you explain how this works. How does AutoML work?
Sure. So, um, first of all, every company that's offering a machine learning product nowadays offers an AutoML feature, right? There are subtle differences between the different features. Data Robot, um, it's kind of their company DNA by definition.
Mhm.
Um, but it's actually not new. I mean, the first commercial AutoML feature that I'm aware of was released, I think, in 1986 by Unica Software. And that was a fairly straightforward, what I would call a harness. It simply it would simply run a couple different algorithms on your data. It didn't prepare the data in any way. It would simply run the algorithms on your data as it existed. And let's call that first generation. And there were a couple of other um, products like that in the 1980s and 1990s. Also in the 1980s, there were tools available, such as classification and regression trees. Salford Systems had developed a capability to automatically test various versions of that algorithm. So, in the 1980s and 1990s, we had single algorithm optimizers. We had generalized linear models, hyperparameterization, and we had sort of simple harnesses. Um, what distinguished Data Robot when it first released its product, which I believe the first release was in 2013, was that Data Robot added feature engineering to that mix. So, in other words, instead of just stupidly running algorithms at random, which can take forever, they would featureize the data, and then their test matrix that they would run would be running not simply an algorithm, but a pipeline, a complete featureization and that's important because the way you featureize the data will depend on your algorithm you're using. Right. So if you're using naive Bayes, you featureize it in one way. Or if you're using logistic regression, you featureize the data in a different way. So auto, Data Robot was the first commercial product that I'm aware of that actually supported automated feature engineering. Nowadays, most of the products that are available in the market do that to one degree or another. The all an automated machine learning product does is it implements a test plan. All right. In other words, it's based on the premise that there's no way to know ahead of time what algorithm is going to deliver the best model for a given set of data. You just have to run tests. And those tests, if you're working manually, can take considerable time to code up and run. What Data Robot did before anybody else did was create not just a sort of a dumb test harness, but it was a harness that featureized the data, but it also used a bootstrapping method to use information from your early experiments to develop better experiment. In other words, there was the combination of the feature engineering plus what they call a meta algorithm that was designed to rapidly develop experiments that would get you to your best model. Others followed soon. I mean, driverless AI is a product from H2O that leverages GPU a platform, and it has a very advanced technique for uh, featureizing the data. Sort of, it works kind of like a Kaggle user would whereas Data Robot has sort of a fixed set of recipes for featureizing data for a specific algorithm. Driverless AI has a more dynamic approach to it.
Mhm.
Um, Truth is, the two products deliver similar results. I mean, that's the essence of it. Basically, AutoML automates a process of running experiments. The difference between the best and the worst is partly a matter of how easy is it to use, Data Robot has a very sophisticated UI. They have engineered their user interface. Spent years and lots of time and releases
Mhm.
making the product easy to use. There are other products in the market that are not as easy to use, but they still deliver a pretty good model.
Mhm.
Um, Almost any AutoML algorithm will develop a pretty good model. All right. So the difference between, let's say, Data Robot or Databricks or um, even SAS has an automated machine learning capability. Difference is more in terms of what kind of artifacts do they produce, what kind of
Mhm.
graphics and information do they provide to the user, do they deliver a code package, or how do they deliver the results and so forth. And so there are differences. And again, Data Robot has spent more time and energy than anyone investing in it, but H2O also has a good product. That's the essence of how they work.
Mhm.
Time series modeling is somewhat different, and Data Robot has a separate product for time series modeling, and that's largely because the techniques are different, the kinds of graphics and user information are different. Um, yeah, I
Okay.
mean, that's the essence of it.
Mhm.
I don't think anybody has anything particularly good for automating large language model development. But I wouldn't surprise me if someone, comes up. And again, there are folks. Mosaic, before Databricks acquired them, had developed some accelerators in that area. So we'll
Yes.
see. But
Okay.
as of now, most of the AutoML products focus on primarily on developing using supervised learning and tabular data.
Mhm. Okay, that's thank you for this overview. So to summarize, AutoML generates many experiments and then uses sophisticated test harnesses to evaluate these experiments and rank them. Now,
Yeah.
as you know, we are working in model risk management, and in model risk, a very important aspect is that you somehow make clear why you make a certain decision. And for instance, if you are evaluating the quality of a model by running some tests, there can be all kinds of trade-offs that have to be made. For instance,
Right.
if I'm building a predictor, then there is a trade-off between robustness of the predictor, like how robust would it be against, say, perturbations of the data, against outliers in my data, and so on, and accuracy, like how precise does the model have to be when I make the prediction itself. And of course, you can quantify robustness and accuracy with a variety of metrics, but to decide what weight you add to each of those requires information about the context. So in those AutoML solutions, how can a user give information about the context so that the test harness will be adapted to the actual business case at hand?
Well, the short answer to that is that some of the tools, and I think Data Robot and driverless AI, both give a sophisticated user control over the model priors, for example. And so, for example, if you're working like in real world problems, there's always an asymmetrical cost matrix. In other words, false positives and false negatives are never worth never as you're either working
Mhm.
in a situation where like in
Yes.
email marketing, a false
Mhm.
positive costs you nothing, a false negative might cost you a bundle, right? So you can adjust the priors of a model, right? But
Mhm.
none of the existing AutoML products that I'm aware of have formal tools built in for risk management. And I think that again, I can't disclose product discussions from companies I've worked for, but I would say that I think that companies like Data Robot and H2O would consider that model risk management to be something more of they would rely on partners for that because
Mhm.
it's a fairly first of all it's a complicated topic on its own right. it's the kind of thing that some customers are very concerned about it, banks, for example, right?
Mhm.
And other customers could care less, right? And so I would characterize model risk management as more of a governance capability, and I think there's an emerging trend in the industry for governance to be a category of its own.
Mhm. Okay, okay, that's clear. Then maybe a related question. So with AutoML, machine learning can be used by virtually anyone as long as you have data, and then you can feed that to an algorithm to be trained. Now, of course, when we build models, a key question is to also understand what are the limitations of the algorithm that has been created. I
Mhm.
understand that, say, model risk management as a governance, or at least the governance part of model risk management, that this is kind of considered to be almost a category of its own and not part of an AutoML product. However, even in a non-regulated industry, if I am a non-technical user who builds a model, an algorithm with an AutoML tool, then it will still be very valuable to understand under what conditions that model will work and when actually it will probably fail. So how is this managed in an AutoML setting? How do you inform non-technical people about the limitations of the algorithm that they have created?
Well, I would draw an analogy to say dentistry, right? I mean, if someone can develops a dental tool, a dental drill that's very easy to use, does this mean anybody can be a dentist? Of course not, right?
Mhm,
And I mean, in my experience as a hands-on analyst, right, developing models or working with organizations, working with hands-on analysts in organizations, um, people people get into a data science role because they're perceived internally as an expert, as a knowledgeable person, and so forth. And that's a combination of knowing methods and procedures and also having domain knowledge. Right.
mhm,
So, um, a, a, a person that specializes in, let's say, marketing models, churn models, response models, offer optimization models, isn't necessarily going to be able to just walk over to the risk management department of a bank and say, hey, I can develop your credit loss models, right? So there's a combination of sort of methodical knowledge and domain knowledge. Now, there's no AutoML tool in the world that actually replicates all of that domain knowledge, right? I mean, I wouldn't be surprised if in the future you start seeing more companies develop. I mean, arguably, Salesforce Einstein, for example, they sort of aim that towards people that are developing response models, that sort of thing. Um, but I mean the standard tools like Data Robot, H2O, Databricks, AutoML, they don't build into those tools any sort of domain knowledge. It's still up to the user
of
to
course.
understand, is this a valid model or not? And to some degree that's going to be based on face validity, right? There's certain kinds of guardrails you can build in other words, I believe that driverless AI, for example, can detect what they call target leakage. Data Robot can detect that as well. um, in other words, the AutoML can detect certain kinds of conditions and
Mhm,
raise red flags. Ultimately, the user has to decide, is this a good model or not. It's all about humans in the loop, all right? And
mhm,
anyone that suggests that AutoML can eliminate that human judgment, I think they don't understand how these work, and they don't understand how organizations work, right?
mhm,
um, just even if you use AutoML to build a model, all right, somebody in the organization is going to need to sign off on whether that model goes into production, right? So,
mhm,
in my experience, when I was working as a marketing analyst, ultimately the 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 executive responsible for the product that I was modeling, right, would ultimately say, yeah, we want this model to go into production or not, because they were paying for it, right?
Mhm.
Similarly, in credit risk departments, you can develop models until you're blue in the face, but still the chief risk officer is going to sign off on that model. And so they're going to need information and artifacts about the model, how it was constructed, how it was validated, how it was tested. Is it sensitive to certain kinds of, in other words, they're going to want to see sensitivity analysis, all that kind of information before it goes into production,
Mhm.
right? And so
Yes.
that you can't automate. I mean, it sounds like your company has tools that support that,
Mhm.
or automate that, right?
Mhm.
But the AutoML products themselves generally, at most, what they're going to do is detect certain conditions that may exist in the data, and give you a warning.
Yeah.
Is that helpful? Does that answer your question?
It does. So indeed, when we talk about model risk management, it's about making sure that, say, everyone is clearly aware of what are the limitations, what are the known risks of using a particular model, and trying to devise strategies to mitigate that risk indeed. So that's the focus of model risk management software. That's also the focus of what we do. When we look at AutoML tools and solutions, from our point of view, this looks like powerful tools to, for instance, quickly generate alternative models to be able to compare, to benchmark, to build this. And this I agree, and this I think we are both aligned on what is the functionality and what is the target user. However, my question was more, if you start making the development of machine learning models easier and less technical, which is ultimately, I believe, the purpose of a company like DataRobot, or the vision or the mission of a company like DataRobot, then I was wondering, does that mean that the typical user of DataRobot would be a less technical person than a typical computer scientist or a data engineer, for instance? And if that is the case, how can we make sure that those people who have less technical understanding of how the algorithms work, they might still have a good understanding of how the business works, but maybe not so much about the underlying algorithms? How can we make sure that they are informed about the risks and the limitations of these algorithms?
Well, it's kind of a complicated question.
Mhm.
And to be honest, it was so long that I forgot the first part of your question.
That's okay.
Let me try to where I think you're going. So first of all, is the purpose of AutoML to make data science easier? I think I think the short answer to that is likely not, right? And
Okay.
that might seem puzzling, but the most important thing that AutoML does is it makes data scientists more productive.
Mhm.
And I'll give you a perfect example of that. When I was at Cloudera, one of the data scientists was working on a problem, and it took him the better part of 5 business days to develop 2 models, right? I took the same data set without modifying it and dropped it into Data Robot and produced a whole battery of models and rank ordered in, I, I think it took no more than an hour, right? So the
Mhm.
point being is that your data scientists are more productive if they're able to automate the tools. Now that said, and again, I can't speak to confidential information of any of my customers, but I would say that the ideal user for AutoML is not going to be, you're not going to have the receptionist at the front desk running models between taking phone calls, right? The ideal user would be, for example, an actuary, or an economist, or a financial analyst, someone who is numerate and has deep
Mhm.
business experience, but hasn't necessarily learned Python,
Mhm.
right? They haven't, they don't necessarily, they don't necessarily want to take the time to learn Python, right? Now, the, there are really two very different kinds of use cases for machine learning in business, right? They're what I would call the casual use cases, right? Where we just want to run some analysis, blah blah blah. It's not never going to go into production or anything. We just want to play around with that. Well, anybody can do that, right? And nobody cares, right? So yeah, some of those kinds of use cases as AutoML tools become embedded in BI tools and desktop tools and tools with a graphical front end, like say Data IQ, then yeah, you'll see more people that really don't have much training or experience or business knowledge
Hmm.
they'll run a regression model or whatever. But for any model that's actually going to affect the business, right? Risk models, right? Patient, in a hospital, models that predict, is a patient going to be rehospitalized if they're discharged? That kind of model that has a serious impact on any organization's, core mission, they're not going to hand it over to people that don't know what they're doing,
Hmm.
right? They're going to have people that are expert, and those people already know how to code. So
Hmm.
the point of AutoML isn't to just sort of democratize everything, like some vendors say, right? We're going to have everybody. I mean, that's not the way business tends to work.
Hmm.
Business tends to specialize roles rather than sort of having everybody do them, and so the point isn't so much to spread the tools around and make them broadly available as it is to just make the people that actually know what they're doing more productive. Does
Hmm.
that answer
Yeah.
your question?
It definitely does. Yes, indeed. So the core audience, the typical user of an AutoML solution is actually a data scientist, and the purpose is to make them more efficient, not so much to democratize machine learning. So yeah, that's
If
definitely
it's
does.
an important use case. Now,
Yes. Yeah.
in contrast, as the importance of the use case goes up, you also tend to have more stakeholders, right? So a model, let's say a credit risk model at a bank, is going to have many different people that are going to be
Hmm.
concerned about it, and they're going to have and so that's where model risk management plays a role, because you need to be able to rapidly develop all the artifacts, tools, and analysis that all those stakeholders need to make decisions about the model that
Yes.
the data scientists built. Does that make sense?
Yes, it does. The question or the challenge will always be on the somehow at the border, basically. So indeed, with credit risk models or with models that are being used in healthcare, for instance, it's very clear that there is a lot at stake and that
Yeah.
there should be, and normally an organization, a business will have proper governance in place to make sure that everyone fully understands what are the limitations and the risks of using a model. And then there is very ad hoc use cases, for instance, amateur machine learning builders who create a model to drive their telescope, for instance, then clearly there is
Yeah.
no risk. But there, and then I understand maybe people use AutoML, but there can
Right.
be these borderline cases, of course, and that's where all the interesting stuff happens. But yes,
Right.
the main ideas are clear. Maybe one last question as we are running out of time, Thomas. Where do you see the future of data science platforms in general, as you have worked for so many vendors, so many organizations? If you would have to look
Complicated question.
5 years in the future, is there anything that you can discuss?
Yeah. Yeah, I mean, first of all, it's a hard question to answer concisely, right?
Yes.
So let's break it into its parts. Where do we see data science platforms going? Well, I think you have to first ask, what are the use cases that are emerging,
Mhm.
and where are those use cases going, right? And there's a clear trend towards generative AI. how big is generative AI? In 5 years, will generative AI be 90% of the use cases for data science, or will it be 10%? I don't know the answer to that, right? I don't think anybody does,
No.
right? People are going to have to figure this out as they go. Um, uh, to the extent that generative AI use cases tend to take over, the platforms themselves will obviously, since generative AI requires much more powerful computing platforms, more data, that has certain implications for what data science platforms will look like. There's some things that are kind of obvious, right? In general, for model development, for model training, cloud platform is the only choice that makes sense. And when I say cloud platform, I don't necessarily mean Amazon, Azure, or Google. It could be a private cloud. But ultimately, since model training requires a burst of intense computing for a short period and then none, you can't really build your entire organization around scaling that. You need pooled computing power. So either you're going to use a public cloud or you're going to use a private cloud, but for model development. Model deployment, on the other hand, is entirely different because your workloads are persistent, repeated, and to some degree predictable, right? And so that in many cases, your deployment platform isn't necessarily going to be the same as your development platform, right? You could deploy model, and I'm aware of customers that do this today. They develop their models in the cloud, but deploy them on-prem. The other, factor is what are the regulatory issues and the data privacy issues that are going to impact AI and machine learning. There are a number of data privacy issues that would tend to um, let's just sort of say that has certain implications on what kind of data you're going to use in your models and to some degree where you train them, right? In other words, if you're unable to physically move your data around, which might be the case, for example, if you have healthcare data in the United States, it's covered by HIPAA. Once your HIPAA data is curated, you can't just simply move it up to Amazon to train your models, right? So those regulatory constraints will affect. My gut feel is that a couple things will happen. One is people will increasingly separate model development from model deployment, and the reason is it's very easy to containerize a model, and so that you don't need to develop and deploy on the same platform. Second, there'll be greater focus on things like federated machine learning and other kinds of distributed machine learning, where the learning might actually take place on different platforms and so forth. But that's just off the top of my head. I mean, my crystal ball is no better or worse than anyone else's. Yeah, is that helpful?
Yes, it is, and it's a very fascinating time we live in with many evolutions. So let's maybe agree already to have another conversation in a few years' time to see how much of that prediction holds true. But I'm sure part of it will be definitely there. So thank you, Thomas, for this great discussion on the fascinating topics of AutoML and AI. And yeah, I'm sure we will have many more questions to
Thanks
follow.
for having me.
Thank
Appreciate
you.
it.
Bye bye.